We're going to be talking about
the sum.
the sums. Okay, and there's formulas for the sums, and just like in the sum for arithmetic series, which means you're separating by pluses or minuses, I only memorized one. This is the one I picked. You can pick either one. Both formulas are exactly the same. They look different. So the one on the left is the one that I memorized. When you look at these things, what you'll notice after the sum symbol is they write down certain things. And in order to find the sum, you need to have three things. You need to, first of all, when you're finding the sum, have a sub 1, because that's in the formula. You also need to have your ratio, because that's in the formula. And you must also have your n, because that's in the formula. So if you have those three things, you can find the sum. Number 7, find the sum of blah, 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 blah. So the first thing I need is A1. So A sub 1 is equal to 3 times 0.2 to the 1 power, because my n starts the counter on the bottom of the sigma with a 1. So 3 times 0.2?
3/5.
0.6 or 3/5. Take your pick. The second thing that I need is R. And in this particular problem, the R is equal to 0.2. It's the thing that's inside the parentheses. The last thing that you need is your n. And your n is how many things will be in this series when you add them all up. Since you start at 1 and you end at 10, if you added them all together, there would be a total of 10 things that you'd be adding. So if I'm trying to find my sum, what that means is I'm going to have my first term, which is 0.6. I'm going to multiply that by 1 minus 0.2 to the 10th power, all divided by 1 minus 0.2. And the funny thing is, most people can do this pretty well up to this point, and then they try to punch this in their calculator, and things go awry. So I would like you to try and pop this into your calculator, and to the nearest 2 decimal places, you should be able to come out with 0.75. Give that a try right now. So the first thing that I need is my A sub 1. A sub 1 will be 32 times 1/4 to the 1 minus 1. Or in other words, 32 times 1/4 to the 0. Anything to the 0 power is 1. So my first term is 32. Not O, 32. Next, I need my ratio. My ratio is the thing inside of the parentheses, so that's 1/4. And lastly, I need the number of items I'm going to be talking about, which would be 6 things. So when I'm trying to find my sum, I know that my sum will be equal to 32 times 1 minus my ratio to the 6th power all over 1 minus my ratio. If you type this correctly into your calculator, I get to the nearest 3 decimal places this time, 42.625. Give that a try. Upon further review, and the NFL referees, not the replacements, I'm going to change my answer based on the recommendation of other people to 656. Is that what you guys got?
Yes.
Fantastic. Good job. In this next part, we're going to move on. We're still going to talk about sums, but from now on, the thing that we're going to talk about is sums of an infinite series. So it is very important to pay attention to see whether or not that you're talking about an infinite series. And when you see an infinite series, that means it goes on forever. So if you ever see that, you will probably be looking for something like the following. Sum, and then there's an infinity on the top. Or you may see something like 1 plus 2 plus 3 plus ... which means it goes on forever. If you see this, or the word infinite anywhere, then when this goes on, what follows next is what you'll need to do. Okay, so it's important to know whether or not you're talking about an infinite series. The previous examples, they did something like n goes from 1 to 6. That means there's only 6 things in the series. Let's look at some examples. First of all, if you know that your ratio is less than 1, and that means the absolute value of your ratio, so like negative a half, positive 1/3, negative 7/9, all of these values are less than 1, not equal to, less than 1 if you take their absolute value. If that's going on, and you have an infinite geometric series, then the answer to your sum is found with the following formula in the red circle. Take your first term and divide it by 1 minus the ratio. If it's infinite and your ratio is less than 1, the absolute value. So I need a couple things. I need my a sub 1 term, and I need my ratio. Looking at number 9, my a sub 1 term will be 2 times 0.4 to the, my counter starts at 1, so it would be to the 1 minus 1, or in other words, 2. So I found my first term. I noticed that in my series, my limit on the top of the series symbol, that sigma, is an infinity. That's how I know it's infinite. So I'm using this formula stuff here. And since I have my a sub 1, all I need now is my ratio. My ratio that I find is the thing that's inside the parentheses. That's 0.4. Is 0.4 less than 1?
Yes.
Yep. So I can use that formula. So now I use that formula. The sum of this infinite series will be my first term, which is 2, divided by 1 minus 0.4. Check that out on your calculators. I believe that you will get 10/3. I would also accept 3.3 repeating, and I would also accept 3 1/3. In number 10, one of the things that we noticed that's different about number 10 is instead of writing it in a sigma format, they write it in a summation format with pluses in between. Is this an infinite series?
Yes.
How do you know?
Because of the dots.
Dot, dot, dot. So I know I'm going to use this formula thing again. I need two things. I need my a sub 1, and in this case, my a sub 1 is equal to 2. It's the very first number. Then I look for my ratio. My ratio is always the second number divided by the first number. So to find my ratio, I will take 0.2 divided by 2, which gives me 0.1. And then I can find my sum of this infinite series because, oh look, my ratio is less than 1. So my sum will be my first term, which was 2, divided by 1 minus my ratio, which is 0.1. When I divide those two things, I get 20/9. As you can see, I like improper fractions. There are other acceptable answers, of course. You could also write, if you want, 2.2 repeating, or 2 2/9. I prefer the 20/9. So in number 11, you can't find a finite sum because the ratio, absolute value, is bigger than or equal to 1. It is, in fact, a 2. So you can't find the sum.